students. In this lecture, we are going to start the topic differentiation of A2 of A level. So this is, you can say that this is the further differentiation. So the formula which we are going to discuss in this lecture, the derivative of e power x, then the derivative of log of x, derivative of sine of x, cos of x, and tan of x. Then after this, we will discuss the extension of these formulae. These are not the new formulae, these are written below. These are actually the extension of these formulae. So e power ax plus b, log of ax plus b, sine of ax plus b, cos of ax plus b, and then tan of ax plus b. Okay, so before this, in AS, we have learned the formula of the basic formula, or you can say the power rule, that is x power n. So how do we differentiate it? We differentiate it like this: power first, and then 1 decrease from power, 1 subtract from power, that is n minus 1, and then the derivative without power. Derivative without power, d over dx of x will give us only 1. So that's why we usually do not write this thing, okay, because this is equal to 1. So the answer is nxn minus 1. Same here, the first formula which we are going to discuss is the derivative of e power x. So the derivative of actually the e power x is e power x. Remember this thing, the derivative of exponential of x equal to e power x. The same, it will remain same, no change in derivative. Hope so you got it. So then the extension of this formula, for example, if we have e power ax plus b, then what should be the derivative of this function? The derivative of this function will be because we know that the first of all, the derivative of exponential will remain same, e power x. So same here, the derivative of this e power ax plus b will remain same. But again, I said this is the extension of above formula. Then after this, remember this thing, derivative without function. Without function, here the exponential is a function, and then we will write ax plus b. We use this thing in all the extension of these formulae which I write here. So the derivative without function, this stand for all, remain for all. So this is e power ax plus b, and the derivative of ax plus b is simply a, because the derivative of b is a constant and derivative of b is 0. So it will become e power ax plus b. So let me give you an example. For example, if we have let the derivative of d by dx of ex, so it will remain same, e power x. But what if we have e power 2x plus 3? Then the derivative will remain same of exponential 2x plus 3, but there is one thing extra, derivative without exponential, and that is 2x plus 3. And we know that in AS, because we have did a lot of question like this, the derivative of 2x plus 3 is 2 only, so it will become 2 into e power 2x plus 3. So this is the derivative. Same here, if we have the function like this, e power x square, and how do we find the derivative of this? Because we know that the derivative of e power x square will remain same, that is e power x square, but the derivative without power, which is x square. And x square, we know that the derivative of x square is 2x into e power x square. Okay, so I hope you got it. So the next formula which I am going to tell you is the log of x, d over dx and log of x. Log of x, the derivative of log of x is always 1 over x. 1 over x, if here it is y, then it will become 1 over y. If here it is t, then it will become 1 over t. If here it is anything, log of x mean 1 over the function f, this is the x, either x, t, y, or anything else. So the extension of this formula, if this is log of ax plus b, always remember this is because we know that it can be when we write x, so I said it can be any number, it can be any function. So here we have ax plus b. So remember one thing always, that it will be so 1 over ax plus b. But then I said the extension of formula, then we have to take derivative without function, which is ax plus b. This stands for all. The derivative of log of x is 1 over this, and then derivative without function, it will be 1 over ax plus b, and the derivative of this is just only a, because the x is 1 and derivative of b is 0. So we have a over ax plus b. So how do we differentiate? Let me take some example. For example, log of x, 4 log of x. We have some constant. We know that whenever we have any constant with function, then we write constant before derivative, and derivative directly operate on the function log of x. This is equal to 4 into 1 over x, and derivative without log dx by dx will give us 1. So we usually do not write this because it gives us 1, so the answer is 4 over x. But what if we have d over dx log of 4x square plus 3? So 4x square plus 3. So 4x square plus 3, we know that the derivative of log of 4x square plus 3, this will be 1 over 4x square plus 3, and then derivative without log d over dx and 4x square plus 3. This is equal to 1 over 4x square plus 3, and then the derivative of 4x square will be 8x, and 3 is, the derivative of 3 is 0, because we know that the constant derivative is 0. So the answer is 8x over 4x square plus 3. This is the derivative of log. And then I'm just going to quickly move on the derivative of here, derivative of sin x, and then derivative of sin ax plus b, the extension of this formula. And same here, the derivative of cos x, and then derivative of tan x, and derivative of cos ax plus b, and then derivative of tan ax plus b. Remember, this extension formula is same for all derivative without function. Just remember only this thing, that derivative without function. Sin x, derivative of sin x is cos x. Remember, derivative of sin x is always cos x. Derivative of cos x is minus sin x, and then the derivative of tan x is secant square x. So what I said, the derivative of sin x is cos x, derivative of cos x is minus sin, and then the derivative of tan is secant square. Okay, remember these formulae, these have also proved. We are not going to discuss their proofs, we are just discussing the formula at how to derivate or how to differentiate, and tan x is equal to secant square. So the extension of this formula, I hope you got my point. The sin x will, sin ax plus b, the derivative of this thing is always cos ax plus b. But one thing, after this we have to take derivative without function. So right here, because I have no space after this, d of ax plus b, and the derivative of ax plus b we know that a, so the answer will be a into cos ax plus b. Always remember this a should written before cos, because if you write a here, then it means this a is multiplying with this angle. Okay, it can be a confusion for someone who is just looking at your answer. So always write this constant before cos, before sin, before tan. Okay, so this is the answer of sine function. So what is the derivative of cos? We know that, remember this formula, the cos derivative is minus sine. So for this function it will be, let me write here, so it will be the minus sine, because this is an extension of the same formula ax plus b, and derivative without function, when you take the derivative without function it will be only a. And I said write this a, I'm just going to shift this a before sine. Okay, so let me remove this one, and then this minus, it will become minus a. Okay, and same here, I hope you got it, this will become secant square ax plus b, and derivative without function is a, and you have to write a before this secant square. So quickly, I'm just going to take only one example. For example, we have the sine 4x square minus 8x. This is the angle. So how do we differentiate it? So we know that the sine formula is sine is equal to cos x. So first of all, we will write this is equal to cos of 4x square minus 8x. But after this, we know that the derivative without function, which is 4x square minus 8x. And the derivative without function will be 4x. If you look at this, we have already learned in AS, this will become 8x minus 8. So derivative without function is 8x minus 8. I said always this 8x minus 8, always write before cos, because if you write with angle, it means that this is multiplying with angle. So this is your answer. If you have any confusion, then you can ask. Thank you so much.